piecewise function is our discussion today. It's piecewise function is kind of a combination of functions. It's two or more functions that are kind of broken up into pieces and put together. So here's an example of a piecewise function where f of x is equal to two things. F of x equals 2x if the x values are under 1, or including 1, but f of x equals 5 if the values are bigger than 3. And you basically look at this graph of f of x, which is here, and realize that this is the line y equals 2x. It has a slope of up to right 1, and it has a y-intercept of 0. But it's only happening, the graph itself only happens at an x value of positive 1 and to the left. It's only happening if x is less than or equal to 1. Here, this is the line y equals 5, or f of x equals 5 is the same thing. It's only happening if the x value is bigger than 3. For all these points, 3, 4, 5, 6, 7, that's the line y equals 5. They're pretty tricky, so I mostly just go over a ton of examples, and you can kind of just pick and choose the ones you want to look at, I suppose. There's two ways to go about graphing these. If you want to graph a piecewise function, one way is to just plug in points, and one way is called erasing lines. And you'll find after a while that I kind of do a combination of these two forms, but I'll start by showing them separately. I have this function, f of x equals x plus 3 if x is less than negative 1. That means for numbers less than negative 1, if I were to plug in negative 2, or negative 10, or 30, sorry, negative 30, all those things would plug into this function. So I make a table that's going to be numbers less than negative 1, and I actually include negative 1. I know that seems kind of odd because this means don't include negative 1, but you do include negative 1 so you know where your open circle goes. So I'm going to go negative 1, negative 2, negative 3, negative 4. Those are points that I plug in for x. Well, if I plug negative 1 into this function here, negative 1 plus 3 is 2, so that'd be negative 1, 2. If I plug in a negative 2, negative 2 plus 3 is 1. If I plug in a negative 3 plus 3 is 0. If I plug in a negative 4 plus 3 is 1. So I have the first point, negative 1, 2. This point here is an open circle. Negative 1, 2 is an open circle. And I have points at negative 2, 1, negative 3, 0, negative 4, negative 1, excuse me, that should be negative 4, negative 1. And it's going to keep on going down like that. Since I have a straight edge tool, I'm going to use it. This graph is going to look like that. There's the first piece of my piecewise function. I just graphed the red part. Now we'll do blue. This is going to be 2x plus 3 if x is greater than or equal to negative 1. So this is including negative 1, but going above. So I'll make a table of values greater than or equal to negative 1. That's going to go negative 1, 0, 1, 2, 3. If I plug in negative 1 here, it's negative 2 plus 3, which is 1. If I plug in a 0, I get a 3. Plug in a 1, I get a 5, 7, and 9. So I'll graph the point negative 1, 1, the point 0, 3, 1, 5, 2, 7, 3, 9. This graph goes like this. And it's broken up into two pieces, a red piece and a blue piece. It's called the piecewise function. If I wanted to give the domain and range, we'll do domain and range for pretty much every graph we do. I prefer interval notation, so I'm going to just do that. This domain is actually all real numbers. At no point is there an x value that I don't get out a y value. Into the tables I can plug anything I want for x, and I get out the y's. The y values are also all real numbers because the graph is pointing upwards and downwards forever and crosses over. So domain and range are all real numbers. For interval notation, I would do this. That'd be my domain and my range, actually. Okay, the erasing lines method is one that people usually don't like at first, But it kind of grows on them because they realize it's easier than plugging in lots and lots of points. What I'm going to do is graph this line entirely. I'm just going to graph the line y equals x plus 3. It's like it's f of x means y, so it's y equals x plus 3. I'm going to graph the whole line. So intercept at 3, slope of 1. And it goes like that. Here's the whole line. But I only actually want a piece of it. The piece that I want depends on where x and y starts. Since I only want a piece of it, I think where is that piece? And that piece is when the x value is negative 1. Well, the x value is negative 1 here, so it corresponds to this point on the graph. That's the point where my graph is going to start. And from there, it's moving it's moving left. So I want to keep all this stuff on the graph and lose or erase all that stuff on the graph. Well, with my smartboard, that's pretty easy to do. I'm just going to do this. Have this go to there. And that is the first piece of my piecewise function. Give this little arrow because it keeps pointing forever. So now we'll do a blue one. I'm going to graph y equals 2x plus 3. Well, y-intercept is 3, slope is 2. So this graph is going to go here. All these points are a little bit off, but I think I can make this work. Yeah, it's going to graph kind of like that. Well, now I check what do I want to keep. I want to keep the stuff where the x value is bigger than 1, but including 1. So I want to keep, negative 1. Well, negative 1 happens here. I'm going to keep everything to the right because it's all the stuff bigger than. So I'm going to lose all the stuff to the left. And it graphs like that. Oh, every time I hit clear screen, it erases all the stuff I had over here. That's annoying. You can go back and find that earlier in the video if you want. Anyways, this was an open circle. This is a closed circle. And there's my piecewise function. Like I said, I'll do lots of examples, but I won't always go through it quite so slowly from here on. This is a finished graph of a 3-piece function. So here we have negative x, I guess we'll do that in black, negative x if x is less than negative 3. Well, here's the whole entire line. It was this whole entire dotted line is the line of y equals negative x. This is the line y equals negative x right here. But all I want is the stuff where x is less than negative 3, which was all that there. Here, this piece was broken in both directions. The blue piece stretches left and right forever. This is the line y equals 2x plus 1. But I lose all the stuff before negative 3 and all the stuff after 2. So I just keep the stuff from negative 3 to 2. That's the stuff that was kept. If I go back and forth, you'll see now that's the stuff that was kept. Here, we only keep the stuff after 5. It's all the stuff after 5, and this is the line y equals 4. So it originally looked like that, but I basically erased all of this stuff right here. All that got erased. In fact, I can probably show that better. Can I get a white pen? I've never tried this before. Yeah, hey, look at that. That's exciting. I can erase all this stuff here because all we want is the red stuff. Okay. Keep on keeping on. I'm going to graph this 3-piece function. This one I'll do by plugging in points. I've got 3 tables. A table where x is less than negative 2, a table where x is between negative 2 and 3, and a table where x is greater than 5. Well, for x is less than 2, even though it has less than and not less than or equal to, I'm still going to plug in negative 2, negative 3, negative 4. That should be enough. If I plug in to this table a negative 2, negative, negative 2, I'm doing negative, negative 2 plus 4, or minus 4, excuse me. Negative 2 minus 4 is 4 minus 4, which is 0. If I plug in a negative 3, I get 1 minus 4, which is negative 1. Plug in a negative 4. 4 minus 4 is 0, because this should have been a negative 2. Excuse me. 2 minus 4 is negative 2. It's going to be an open circle where I start. So at negative 2, I have an open circle. Then I have negative 3, negative 1, negative 4, 0. And this graph is going to go there. There. There's my first piece. Second piece runs from negative 2 to 3. And I end up putting in negative 2 twice, because it happens here and here, but one of them is an open circle. This one's going to be a closed circle. So it's not overlapping, and that's okay. So I'll go from negative 2 to 3. If I plug in a negative 2 to this function, I just get out negative 2. Negative 1, 0, 1, 2, 3. So that's nice and easy. This is just the line y equals x. So the point negative 2 actually fills in that closed circle, that open circle there, which is a little bit odd. That'll happen sometimes, but not often. This is also a closed circle here because it has the equals to. The equals to it makes it a closed circle. This is going to be a blue line that doesn't need an arrow anywhere. Graphs like that. Then my last piece is x is greater than or equal to 5. And then plugging into this function. No matter what I plug in for x, 5, 6, 7, 8, 9, no matter what I plug in for x, I'm going to get out a 3. Give me 1 second. Somebody's knocking on my door. Excuse me. Whatever I plug in for x, I just get out negative 3, because this is the line y equals negative 3. So starting at 5, it's that. There's my 3-piece piecewise function. Now for my domain. A domain is all the x values, and if I think about a scanner and where this graph is hitting a scanner, this will be a blue scanner, hit the graph, hit the graph, hit the graph, hit the graph, I stop hitting the graph right here at 3. So this is going to be everything where x is less than 3 or equal to. So I'm going to write that. You can write x is less than or equal to 3. If you do that, you're really doing set builder notation, so you want to do this. It's also going to be everything where x is greater than 5. If you want to do it with interval, we'd go from negative infinity to 3, and then from 5 to infinity. But what's actually really nice is this is just your domain. It's listing all your x values for you right there. That's your domain. Your domain is everything written in that little green circle. It simplifies a little bit because of this overlap. Because of this overlap, I didn't have to write all that stuff down. It's just less than 3. But that's what it is. Okay, for range, range is your y values. I look at this graph and I start at the bottom and I scan upwards. I'm not hitting the graph here. I'm not hitting. I hit it at negative 3 really briefly. So my range is going to include, it's going to equal negative 3. And then it hits negative 2 right here. Here's that negative 2 it's hitting. It hits negative 2 and goes up. And it goes up forever because of that arrow right there. So it's negative 3, it's equal to negative 3, or it's greater than or equal to negative 2. You can also just say, if you want to do interval notation, the range is the number 3, which I guess I'd put in a box. That's a little bit odd. And it's also from negative 2 to infinity. This one I'll do by erasing lines. Whoa. First I'll graph the line y equals 3x plus 1. It's this one here. Y equals 3x plus 1. Looks like this. I only want to keep the stuff where x is less than negative 2. Well, x is negative 2 right here. So I'm going to keep all of that to the left. I keep everything to the left because it was a less than. So it goes there. And that's going to be an open circle at -2, -4. I think it was -2, -5, though. I should probably go back and check that. I think I lost a spot as I rolled. Yeah, it was at -5. I should keep this mark here, circle it, then go down. Okay, there's one piece. Here's my blue piece. Now I'll do y equals 1/2 x. That'll be my red piece. Y equals 1/2 x starts at 0, has a slope of 1/2, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. So the line goes here. I want to keep everything between -2 and 3. Everything from -2 to 3. So I'm keeping everything from here to here. So these are closed circle on the left, open circle on the right. So it's here to here. There's the middle piece. Then for the right piece, -x plus 2, let's do that in green. So I'm going to graph the line y equals -x plus 2, which looks like this. Slope is -1, so down 1, right 1. The stuff I'm keeping is bigger than 3 with an open circle. Well, 3 happens right there. So I'm keeping everything bigger than that. Going down. So I can erase all that. There's my piecewise function with 1, 2, 3 pieces. Now the domain of this one is a little bit weird. The domain is actually all real numbers except for 3. 3 never happens because of those 2 open circles. So one thing you'd say for your domain, if you want to do your set notation, it's set of all numbers x such that x is not 3. It's easier to say what it's not, but if you wanted to, you could also say it's a set of all numbers x such that x is less than 3 and x is greater than 3. That's really, remember I said this is actually your domain, but that can really be simplified because you realize it overlaps here and it overlaps here. There's 2 points where it overlaps. For range, I think about my scanner going left to right. Sorry, it's pointing left to right, going down in this case. I start at 1.5. That's exactly at 1.5 because the slope is 1/2. It doesn't include 1.5, but then as you go down, it's hitting the graph somewhere. Even here, I'm hitting the graph way out here. You're always hitting the graph somewhere, and it goes down forever. So it's going to be the set of all numbers y such that y is less than 1.5, not including 1.5, or in interval notation, you could say it's going from 1.5 to -infinity. And interval notation here, this would be -infinity to 3 and 3 to infinity. Everything except for 3. Okay, I think that's all of those examples. Now the other piece, I know this is a long video, but you can jump around. The other piece is how to make the equation from a graph. A lot of people find this tougher, some people find it easier. The nice thing is, you know it's going to start with one of these fun wing brackets. And you get to draw that and think about your 3 pieces. First you can think about where these pieces happen. This piece has x values from -2 to the left. So now the first piece will be less than -2. I don't do the equals to because it was an open circle. Then I ask the question, what's the equation of that line? Well, for now, all these lines we're doing will cross through the y-axis really cleanly. Up 1, right 2, up 1, right 2, up 1, right 2. This would have had a y-intercept at 5. So it's the equation y equals 1/2 x plus 5. The 1/2 is my slope. the 5 is my y-intercept. It doesn't actually have a y-intercept the way it's graphed because it's a piece of the graph, but had it continued forever, it would have been 1/2 x plus 5. So for the middle piece, the domain is going from -2 to 1. These are both closed circles, so I should have the equals 2's on them. This has a slope of down 3, right 1, down 3, right 1, so that's -3x. It has a y-intercept at -3. So it's really the line y equals -3x minus 3. There's the y equals, there's the -3x minus 3. The third one is actually the simplest, but people kind of get confused by it. I know that the domain is starting at 2 and going to the right, so x is greater than or equal to 2. But the y value is just always 5. This is just the line y equals 5. It's not changing depending on what x is. X has no impact on the y value here, so it's just y equals 5. There's the graph, or the equation for that graph of the piecewise function. If we wanted the domain, real quick, I would go -infinity to 1 and 2 on. Or I could say x such that x is less than or equal to 1 or greater than or equal to 2. There's my domain in interval form or in set form. The range, y equals 5 or y is less than 4. Less than or equal to. Nope, just less than. Or in interval notation, I would say 5 or 4 and below. 4 and below means from 4 to -infinity. Next one, this has 3 lines again. This has a slope of 3 over 2, so 3 over 2, it would have had a y-intercept at 1. So this is the line y equals 3 over 2x plus 1. And it's happening when the x values are less than or equal to 2. Did I have the ifs on the other one? No. This should say if in between everywhere. Middle one, this is just the line y equals -2. And it's going from -2 to 2. This is the line, has a slope of 1, and it's going to cross at -4. So it's x minus 4 if x is greater than 2. The domain is all real numbers that are not 2, so I would write that like this. Or in set notation, or interval notation, I would go from -infinity, gosh, I'm trying to go fast and I'm getting sloppy, -infinity to 2, and 2 to infinity. The range is everything below 5, including 5. I believe that's all my examples. We're not going to do that today. I know this was a long video. Thanks for bearing with it if you watched it all.